right, have your homework out, and your book's open to page 158. You did number 17 and 19, a couple of systems of equations there, and then page 163, you did review numbers 13 and 14, most of you, and a couple systems there to graph, so 4 graphed systems of equations. And I'm using that term system of equations. Plain English, what is a system of equations, Noah?
It's like all the equations to make the answer.
Help him. Okay, so the key is, it's not like, because for instance, we've worked equations before, right? Like I'll give you, okay, solve these 6 equations. Is that a system of equations? Because I tell you to do 6 of them? What makes the 2 equations a system? You get one answer with 2 different values in that answer because the 2 equations have to work together. They're solved together. As opposed to in the past, I said, all right, class, solve these 6 equations. Well, they're all separate individuals. They have nothing whatsoever to do with each other. These 2 equations do work together. You solve them together. You need the information from both of them to get your answer. And again, so far, all we've done with systems is graph them, because graphing really helps us to understand the foundations of them. And then today, here in just a few minutes, I get to teach you all one of the shortcuts. There's actually 2 shortcuts. I'll teach you one today, and then a couple days from now, I'll teach you another one, and then you kind of get to pick which shortcut you like better. Or each situation, you might feel like this is better. For instance, like with graphing, right? Sometimes we do intercepts, sometimes we do slope-intercept form. Just depends on which one we think is easier in that case. So I'm going to give you a couple of options on systems of equations other than graphing, because frankly, it takes a long time and is annoying. But we said that the reason we need 2 equations for these 2 unknowns, x and y, is because one equation by itself is, Noah, back to you. Did you study last night? No, it shows. Brecken? Did you study last night? No? You didn't study either. Ah, okay. You're gonna learn the hard way soon. Indeterminate. Say that, class? Indeterminate. Okay, one linear equation, indeterminate, meaning you cannot determine an answer from it because there's too many of them. The whole line consists of possibilities, but how do you know which one's the right one or the one that's desired? We said that that's why we use the system, that second equation. The idea is that the 2 equations will cross each other, and where they do, that's our solution for x and y. And so we get our 2 unknowns from that one point of intersection. If the 2 equations intersect each other, we have a system that's called a consistent system of equations. But it's possible the 2 equations may not intersect. Our first equation might go right here, but our second equation, for instance, could run parallel to it, in which case they wouldn't intersect. Well, what would our answer be if the 2 equations run parallel and don't intersect? It's called an inconsistent system. What would the answer be? There isn't one, right? There's literally no solution because they never intersect each other. It is possible that 2 equations could actually coincide when graphed. The equations are referred to as being, well, the solution is indeterminate, right? Because there's still an infinite number of solutions. That doesn't exactly help us. But the equations, with relationship to each other, I would describe the 2 equations as being dependent if they coincide the one with the other. Whereas normally we draw a line, we draw some other line. It may be parallel, it may intersect, but as long as the lines are distinctly separate, distinctly different, then we would refer to the 2 equations as being independent. So what we really want is a consistent system of independent equations, because that makes life easy. They cross, you get the answer. Okay? We could also get an inconsistent system of independent equations, parallel lines. Again, a consistent system could have dependent equations, in which again is still indeterminate, like a single linear equation. Make sure you study. That said, let's take a look at page 158, numbers 17 and 19. Starting with number 17, we were given the equation 3x negative y is equal to 13, and then 2x positive y is equal to 7. As we go to graph this, intercepts or slope-intercept form, Maddie, for this top equation here? Intercepts, all right. So the x-intercept would be 13 thirds, which is what, 4 1/3? And then the y-intercept would be negative 13. Boy. Okay, so in a quick sketch, I'm going to give myself a lot of room down here. 3, 6, 9, 12. So negative 13 we write about here, and then 3, 6. So this would be 4 1/2. 4 1/3 we write about there. So we're going to get a line something like that. All right, then for our other equation, intercepts or slope-intercept form, Noah. All right, what does it become in slope-intercept form? All right, where we need to plot our y-intercept at. And from there we need to run backward. So rise 2, and then run backward 1, and we get a line that looks something like that. Now again, without an actual graph grid, it's kind of hard to project. Looks like this is about negative 1 1/2 in the y, and looks like it's right about 4 in the x, so 4 negative 1 1/2. But remember I told you, when in doubt, try a whole number if you're not sure, and probably it would have worked out neater if I'd done it on the graph grid, but for sake of time I won't. So 4 negative 1, 4 negative 2, someone give an answer like that? You did? You did? What answer did you get? 4 negative 1? 5 negative 2? 4 negative 1. Let's try their 4 negative 1 real quick. 4 negative 1, that'd be 12 plus 1 is 13. 8 plus negative 1 is 7. So yeah, the 4 and the negative 1 would check, 5 and negative 2 wouldn't. So 4 negative 1 is our answer there. Questions on that system of equations? All right, questions at all? And Rebecca, you came up with something a little bit different. Okay, let's take a look at the next one that you had there, number 19. We had a 2x positive 2y is equal to 11. 3x negative 2y is equal to 14. And top equation, intercepts or slope-intercept form, reckon? All right, so what do we get? And then divide everything by to get y is equal to negative 1x plus 11 halves is really 5 1/2, right? 2 goes in 11, 5 times 1 left over, so 5 1/2. So we'd have to come to, let's see, here would be 4, here would be 5, there would be 5 1/2, and it's going to be up 1, backward 1. Okay, something like that. And then for this equation, Maddie, intercepts or slope-intercept form? All right, what do we have here? And then, of course, divide everything by. Now, if this were an inequality, we'd have to flip the sign, but it's not an inequality. We'll cancel the negatives and the 2 to get y is equal to. All right, so here we're going to start at a negative 7. We're going to rise 3 and run forward 2. And almost looks like it intersects right on the, kind of hard to tell here. It almost looks like 4 1/2, 0, but I don't think that's right. In fact, I know that can't be right. What did you get for your answer, Maddie? You got 5 1. Okay, so maybe my line should have been something a little bit more like that. Maybe I kind of dropped down here, so you're saying right about 5 1. I can see that. Anyone else get 5 1? Same answers, Maddie? You did not. What did you get?
5 0.
50, because I was kind of around that mark as well.
I'll put a positive 7, and I got it.
Oh, so you're just way off. Okay, let's try the 5, 1 real quick. Nope, that's going to come out to a 12. So I know it can't be 5, 1. You said 5, 0. That'd be 10. That can't be right either. It ends up actually being, if I cheat and look at my textbook, for number 19, actually comes out to 5, 1/2 is what it should be. Isn't that annoying? That's why I don't like graphing. It takes forever, right? I don't like this at all, to be quite frank. Especially considering I could solve this in my head and get 4, 1 that quickly. I could solve this in my head and get 5, 1/2 that quickly with what I'm going to teach you here in just a few minutes. Way beats this method. Now, I don't know if you'll be quite that fast because you're not the math teacher, but you'll be close. You'll be close, especially with these particular systems. You'll understand why here in a little bit. Let's look over to page 163. Page 163. And since the graphing turned out bad on my part when I was freehanding it, I'll go ahead and put these on the graph grid. Our last 2 graphs we'll do today, and then we're done with graphing for today. We'll review it here and there on other days, but today we're ready to move on. Page 163, review number 13, and Brecken, what's that first equation in the system?
2x plus y equals 6.
2x plus y equals 6, and the next equation, 3x negative y equals 4. The answer is 2, 2. Anyway, but let's go ahead and graph it since that's what we have to do for this. I know, it's frustrating to have to do all this graphing stuff. Alright, so I'll get some label stuff on here. Brecken, top equation, we do it intercepts or slope intercept for? Intercepts. All right, what's the x-intercept? 3, 0. What's the y-intercept? 0, 6. All right, and I'm going to, if we're going to do it right, we'll do it right. Let me get the straight edge, and let's graph the straight line. All right, next equation, intercepts or slope intercept for? I think that's a good choice. What you got? Be careful, negative 3x, right, if you're moving it over. And then, right, basically just change all the signs to get. All right, so y-intercept of, then we're going to rise, run, forward 1, and we connect the dots. And there we are at 2, 2. Did you get 2, 2 for number 13? You didn't get 2, 2. The questions on how Brecken solved it just now? All right, let's go ahead and take a look at the next system, number 14. And we've got an x minus 2y equals negative 4, and then y plus 2x equals 2. I feel like this system is easily solved by the intercept method. Noah, top equation, what's my x-intercept? If I plug in the negative right here, or I plug in the 0 for the y, what do I get? Negative 4. So plug in the 0 for y, I get negative 4. What about the y-intercept?
2.
Good, positive 2. All right, so there's my first equation. And for the next equation, Maddie, now be careful here, what's the x-intercept? 1. You're plugging 0 in for y. Now the values are reversed of what we're used to seeing. We're still plugging the 0 for the y. Get x is equal to 1. All right, and then what about the y-intercept? 2. Oh, that's easy. They obviously intersect right here at 0, 2. Questions on that? Did we get 0, 2 for number 14? Questions on that? All right, so done with graphing for a little bit. Next section of your notes. Solving systems of equations. And we got through Roman numeral 1, which was graphing. But let's take a look at Roman numeral 2, which is a method I call addition or elimination. So solving systems of equations, Roman numeral 2, addition / elimination. The addition or elimination method. I'm giving you both names because depending on the math text you look at, it could be called either of these names. I believe our textbook refers to this as the elimination method, but you'll see other textbooks that will refer to it as the addition method. They both work very well. A couple things about this method that I like that you've already caught on. Number one, you can be a lot more accurate. You can be a whole lot faster. You don't have all the frustration of the line not quite meeting up perfectly and you're trying to guess what's kind of around here. So maybe is it this? No. Maybe is it that? No. Maybe. You don't have to mess with any of that. All the frustration is gone. Here are our steps in solving a system of equations by the addition or elimination method. Step number one, line up like terms. Line up like terms. We want the order x, then y, then equals, then number. We want that order. It's actually called the general form of a linear equation. You'll learn that later, but we see this format a lot anyway as we look at the systems. There usually are x, then y, then equals, then number. So for instance, if I gave you the equation 3x plus 2y equals 7, notice I've got x, then y, then equals, then number. But if I had something like 2y negative x is equal to, say, 3, well, that's not x, then y, then equals, then number, is it? And so what I want to do in the system is to rearrange the equations as needed so that like terms are lined up, so that x's are both in the first spot, y's in the next spot, equals, then number. What would I need to do to rearrange this? Not really that hard, just need to be careful. Noah? Good. Not switch the x and the 2y, but put the negative x and then the positive 2y. Excellent. Remember, the sign goes with the term. So good job on that switch. Common mistake, students just put x minus 2y. No, it's negative x positive 2y. Step number 2. Step number 2 is to pick a variable to eliminate. Pick a variable to eliminate. This is why our text refers to this as the elimination method. It comes down to this, class. We're used to solving equations, but we're not used to having 2 letters. We're used to having 1. Usually we're used to having x, correct? So if the second number second letter sort of gets in the way, we're going to pick a variable to eliminate. Now there's a best choice here. There's a strategy to this. In order to eliminate a variable, you need to have the same number and opposite signs. In order to eliminate a variable, you must have the same number and opposite signs. So as we look here at the x's, notice the x's have opposite signs, but they ain't got the same number. Look at the 2 y's. They have the same number, but they ain't got opposite signs. I'm going to have to do some multiplication to make this happen. It's going to require some multiplication to make this happen. I've got 2 options. If I want to get rid of the x, then these both need to say 3x, don't they? Waiting for Maddie's eyes once she's done writing. Does it make sense? If I want to make these x's knock out, I said I have to have the same number, opposite signs. Opposite signs were good. They just don't have the same number. They would both need to have the number 3 right here, correct? If I multiplied everything by 3, it would now have a negative 3x, correct? They would be able to cancel or eliminate. The other option would be, well, instead of multiplying everything by 3, what if instead I said, well, let's get rid of the y's. They just need to have different signs. So I can either change all the signs in the top, multiplying by a negative 1, or change all the signs in the bottom, multiplying by a negative 1. We're going to let Brecken pick. Do you want to get rid of x or do you want to get rid of y? Get rid of y. So we're going to go ahead and change all the signs in the lower equation. That's basically multiplying a negative 1. And now notice what we have. Same number, 2y, opposite signs. One's positive, one's negative. So that in step 3, we will add the equations. We will add the equations. This is why it's referred to by some texts as the addition method. I take these two things and I add them together. 3x plus positive x class equals 4x. 2y plus negative 2y, eliminated, canceled, gone. 7 plus negative 3. And would you look at that? I have an easy little equation that you would have solved back in elementary school. So of course, it kind of makes sense now, but solve the equation. Solve for the first variable. Solve for the first variable. Yeah, pretty easy. It's what you would naturally do anyway. As soon as you saw 4x equals 4, your brain's already thinking x equals 1, or at least it ought to be, right? So remember, I'm solving for two things, x and y. Well, I now know that x is 1, but I don't yet know y. How do we figure out y? Well, now that you know that x is 1, I could go back to one of my original equations, and I could replace a 1 for the x. I can't plug anything in for y because I don't know it, but I know that x is 1, so I just plug that in. So that's our next step. Number 5 is to plug in this answer, meaning what you just got when you solved for the first variable, plug in this answer to one of the given equations. Plug in this answer to one of the given equations. In my case, I'm just going to take the first one. It's now 3 times 1 plus 2y equals 7. Well, we can do 3 times 1, class. 3. In fact, then we could move the 3 over to the other side as a negative to get 4. 2y equals 4. And then obviously y just equals 2. So we're going to plug in this answer to one of the given equations and solve, as I just showed, for the second variable. Solve for the second variable. And the last step, I've actually already done it, but we want to write our answer as an ordered pair. Write the answer as an ordered pair. That's another name for a set of coordinates. It's a pair of values in a particular order, x then y. So there's my answer, 1, 2. Let's do another one. This time do this with me if you would. Please write this down on your paper. 4x positive 3y is equal to 17. 2x negative y equals 11. 4x positive 3y equals 17. 2x negative y equals 11. What do we need to do first, Maddie? Thoughts? They're already lined up. A lot of times this first step will be done for you. Nice. All right, so we go to our second step. Noah? I'm sorry? Pick a variable to eliminate. Which variable do you want to eliminate, Noah? The x or the y? The x? Now, I will say the upside to getting rid of y, Noah, is that they already have different signs, right? But we can get rid of x. It's your choice, right? Just like in a magic trick. You have a free choice. You pick whatever card you want, all right? But Noah, in order for the x to actually get eliminated, I have to have the and. What number would I want both 4 and 2 to turn into, class? 4. Could I do 8? Sure, multiply by 2 and by 4. But it's easier to get a 4 because then all I have to do is multiply the bottom equation, class, by 2. So let's go ahead and multiply the bottom equation by 2. I'm going to keep the 4x plus 3y equals 17. Noah, distribute the 2 to get
4x.
all right, and now I have the same number. But I don't yet have, class, opposite signs. So then as a second step here, because we didn't have opposite signs to begin with, we need to change all the signs in the top or all the signs in the bottom equation. Brecken, which one? Bottom equation. So my 4x becomes, my 2y becomes, and my 22 becomes negative. All right, once I have same number, opposite signs, then, Maddie, we simply add the equations together. And when I add the equations together, Maddie, 4x negative 4x, 3y plus 2y. Be careful here, 17 negative 22 negative 5. Subtract, keep the sign of the greater absolute value. And now the next step just screams at you, solve it. And Noah, we get y equals negative 1. Again, I'm going to kind of jump ahead to my last step of the ordered pair. I'm going to want to put the negative 1 in for the y spot. But that's only half my answer bracket. I'm not done. I need x and y. I only have y. How do I go about getting x? Good. Plug in the answer we just got, this negative 1 for y, into one of the original equations. Usually I take the equation I ain't messed with yet. I messed with the second equation. I'm going to take the first equation, and in for the y, make sure you plug in for the right letter. Wouldn't that be a shame to plug in for the x and really screw this up? Make sure you plug in for the correct letter. We'll plug the negative 1 in here for the y. Of course, we know that 3 times negative 1 Brecken, but I can move the negative 3 over to the other side as a, to get 4x is equal to 20. Apparently, Brecken, x is equal to 5. So we plug it in, we solve, and in my case, I've already written the answer. As an ordered pair, 5, negative 1 is our solution. Questions on that? You might recall number 13 from the homework. We have the equation 2x plus y equals 6, 3x minus y equals 4. I looked at the equation and I said the answer is 2, 2. Do you remember that? Here's what my brain was doing. I've already got same number, opposite signs, don't I? Everything's lined up. I could go straight to mentally adding to get class. So x obviously equals 2. I then plugged in the 2 here to get, and then moved it over as a negative 4 to get 2. See, you could do it too. It's not that I'm super smart or super special necessarily. You could get 2, 2 that easily as well, since they were already lined up. Flip back in your books to page 158 for a moment. Look at number 17. Do you see how the positive and negative y are already lined up and cancel just like that? 5x equals 20. X is 4. Plug the 4 in, get your negative 1. Look at number 19. Do you see how the positive and negative 2 y's were already lined up? Gone. 5x equals 20. 5x is 5. Plug that in. End up getting the 1/2. So much quicker, right, to use this addition method. If you would, go ahead and turn now in your textbooks to page 166. Page 166. And go and copy down problem number 2. Problem number 2 onto your paper. Page 166, problem number 2. Thoughts, Brecken? Isn't that nice of them to give us something that's already neatly lined up, things already set to cancel? So all I've got to do with the equations, class, is add them together. Hence, I call this solving by the addition method. And as I add them, what do I get for my x, class? 7x. My y's cancel, equals 21. X then apparently equals 3. Am I done? No, I'm halfway done. I know my x. I still need the y. What do I do to get the y, Maddie? Go to the first equation, okay? And we make sure we plug it in for the x. So 5 times 3, 15. move it over as a negative 15 to get negative 3y equals 21. What is y? Negative 7. And there's our answer. A lot quicker than graphing, a lot less frustrating than graphing. Do number 4 at your seats. Do number 4 at your seats. Pencil down when you've got it. Maddie's got it. Come on, guys, she's got beat by a girl. Somehow it's more painful in PE for that to be the case, right? But I think they've kind of conceded volleyball as this is just where Maddie's going to shine. All right, what'd you get for the answer, Maddie? 1, 1. Did y'all get 1, 1? Good. Hopefully you canceled the x's straight out. 8y equals 8, but you could have done that in your head, right? To get y is 1. And then you plug the 1 in here. 3 times 1 is 3. Move it over to negative 3. 2x equals 2. X equals 1. And we're done just that quickly. Now look back at number 3. Write this one down now. Oh, the niceness wore off. They're not nice anymore. Because nothing is set up just to cancel beautifully for us this time, is there? Man, we got to pick a letter to get rid of. And Brecken, you thinking X or you thinking Y? Why are you thinking Y? Right. Both are going to end up with a 2 as your number of choice, right? That's a pretty easy number either way. But these already have different signs to where once you multiply the 2 through the top to get, Brecken, you said, yeah, once you got that 4x negative 2y equals negative 18, now the y's are set to cancel right off. We don't even have to go through it, also change a sign anywhere. So the positive negative 2y's cancel. I add my x's class to get 5x. I add the other side, the negative 7. By the way, big mistake a lot of students make. They'll say 2 times 2x, 4x. 2 times negative y, negative 2y. And they'll say equals negative 9. Everything gets the 2, right? We're distributing it all the way through. So make sure we also get it to the negative 9 to get the negative 18. Over here, class, we now add to get negative 25, add and keep the sign, meaning x is negative 5. Halfway home, there's our x. We just need y. And so let's go to this equation that we haven't messed with yet. And let's plug in our negative 5 for the x. Well, I can't leave it here. I need to move that negative 5 over, class, as a positive 5. What does my equation look like now? Two y equals negative 2. So apparently y is negative 1. Good. Questions on this? Feel like you're getting the hang of it? All right, let's look at number 5. Actually, you do number 5 there at your seats. You do number 5 there at your seats. Noah's got it. Brecken's got it. Way to represent, guys. I don't blow it and get the wrong answer. All right, Brecken just said, no way we got this wrong. So, Brecken, what did you get for your answer on number 5?
-1, -1.
Good job. Did you get -1, -1? Did you get -1, negative? Well, hey, you know, a guy still won. Good job, Brecken. Nothing personal, Maddie. -1, -1's our answer. Let's take a look real quick. You should have canceled the positive -7y's. Yes? Everyone did that? Add the x's to get? And at the other side, you get -7. Did you get -7? Subtract, keep the sign of the greater. That's where the first -1 comes from. No, I assume you got the x is -1. So you lost your negative. Careful with the negatives. Then you'll plug the -1 back into either equation, end up with the -1 for the y value. Number 8. Number 8, copy it down. 5x negative 2y equals 10. X positive 4y equals 2. Nothing lines up this time. Maddie, what are you thinking to make this happen? Good. You could either multiply the first one by 2, which would give you the matching 4y, or you could multiply the bottom by a 5 to get the matching 5x. But I like Maddie's choice because the signs are different. These signs aren't. So I like getting rid of the y, multiply everything by 2. Maddie, what does your top equation become? And of course the bottom equation will remain for now, x positive 4y equals 2. Now that we have same number, opposite signs, no, we simply add them together to get. So obviously then x equals 2. Once we know that x equals 2, we can plug that back in for x in one of our 2 equations, Brecken. Bottom one. We're plugging the 2 right here, so it's now 2 plus 4y equals 2. Hey, if you need to rewrite that, instead of trying to do it in the same line, that's okay. No shame in having to do the rewrite. What do I do now to solve for the y, Brecken? And that'll give me 4y is equal to 0, and then just divide away from both sides to get y is equal to 0. All right, so 2, 0, our answer. Questions on number 8. Number 9, go and copy it down. Don't you like how easy this is? And what do we do here? Noah? Cancel the 3 x's to get.
6y equals 14.
And divide both sides by 6 to get y is equal to 2 1/3. You could, since we're not graphing, leave it as 7/3 or 2 1/3 either way. Oh, this just became not fun because I have to plug that in for the y. I really hate fractions. Strategy tip for you, class. You listening? If you get a fraction, don't plug it in. Be lazy. It's actually easier for you to say, all right, fresh start. We got rid of the x's last time. Now let's get rid of the y's. The reason you got an answer for y is because you canceled the x's. Let's just start over. We've got our y. Now let's cancel away the y by multiplying the bottom equation, class, by 2. I'm going to keep for now the 3x positive 4y equals 6. My bottom equation bracket is going to become there we go. And now I can cancel the y's, right? No, because I got the same number, but I still need to get the opposite sign. So let's change all the signs across the top or bottom. Bottom, okay. So we'll make this a positive 6x, negative 4y, negative 16. Now the y's cancel. That's going to give me 9x is equal to, careful, negative 10. Keep the sign of the greater. And then divide away the 9 and either get negative 10 ninths or negative 1 1/9. Oh well. Can you imagine trying to solve this by graphing and figuring out that 2 and a third, not 2 1/2? Negative 1 1/9, and not just negative 1. You wouldn't be able to do this with the graphing method. You'd never know what the correct answer was. And if you try to check it, you just get frustrated. But with the addition method, even when it's not ideal, normally I'd like to just plug the y back in, wouldn't I? Well, there's still a backup plan. Just get rid of the other letter. That wasn't that hard. And now we've got an accurate answer, an accurate ordered pair class of negative 1 1/9, 2 1/3. Again, you could also say negative 10 ninths, 7/3 if you're lazy, which is normally what I do, because I'm lazy. Questions on this? If you get fractions, don't try to plug them in. It is not worth it. When it's that easy to get the answer the other way, right? Does that make sense? All right. Do number 10. Do number 10. Noah's finished. Noah, let's talk through what you did while they finish up.
I multiplied by 2.
Top by 2 to get
4 negative 6y equals negative 22.
all right. So now there's our system. What next?
Change the signs on the bottom.
So what was the top has now moved. I just happened to move it to the bottom. Didn't have to, but make this negative, this positive to get
11y equals 44. And y equals 4.
All right. Then what?
Plug the 4 into the top.
Up here or down here? Right here. Okay. And again, making sure you plug that in for the y. So that really gives me.
20.
And then what did you do with the 20?
Bring it over to get 2.
So we end up with 4x equals 2. So your answer was?
A half.
Great job, Noah. Did you two get a half 4 for your answer? You did not. You did not. Check your work. Did you try to get rid of the x or the y? X, so you both of you multiplied the top by 2. Did you get 4x negative 6y equals negative 22 initially? Did you still have the negative 11, Maddie? Well, no, you should have had 4x negative 6y negative 22 initially. And then you'd go through and change all the signs. Let me take a look at your work. Noah, go ahead and take a look, work the next problem. I think that's number 11. Brecken, did you find your mistake? We're up here. That's the problem. That's not number 10. You somehow almost worked 13, but not 13. That's why you did the wrong problem. All right, Brecken, let me take a look at your work. Go on to number 11, Maddie.
I kept that one negative. I multiplied it by -2.
Ah, I gotcha. Okay. So you changed all the signs. You didn't change all the signs. You forgot about the last one that messed everything up. Okay, go on to the next one. Again, the reason we want to identify those mistakes is so we know, okay, this is something I'm prone to do. Let me avoid making that mistake moving forward. Yeah. Okay. Well, it looked easy, right? Once you get that X answer, you're like, I'm plugging that back in. For sake of time, stop where you're at. See how you were doing. Were you on the right track here? I assume you canceled the two y's, right? Just right off the bat, 6x equals 112. 6 goes into 11 once with 5 less 6 go to 52. 8 times with 4 left. Oh, 18 2/3. Did you get that answer? And then did you be like, I ain't plugging that in? And you resolve, you say, forget the y's now, I'm focused on the x's. I'm going to multiply the bottom through by a 5 to get 5x negative 10y equals 40. Change all the signs to make this negative 5x positive 10y negative 40. X's cancel, 12y equals 64. 12 goes in 5 times 4 left over, so 5 and 4 12, so 5 1/3. Anyone finish? You did? You had a little bit of a head start on the others. Were you on the right track at least? You're going to do 2 for homework. I know it's a Wednesday, but if you don't do homework, you will not remember. So page 166, numbers 6 and 12. Page 166, numbers 6 and 12. So just 2 problems for homework. Now, if you want to do a third one for some extra credit, number 23. And it does actually work out evenly. This is not a hard extra credit. Okay, so page 166, number 23 is for extra credit. 6 and 12 are homework. 23 is extra credit. We'll take a look at this in tomorrow's lesson. We'll make sure that by the end of the day tomorrow, you've got this method down really, really well. Have a great rest of your day, and you are dismissed.